Hey guys, and welcome back to an amazing new long video today in which we'll build something very amazing. What we'll build will be an online tic-tac-toe game which you can play with your friends in real time. So if you finish watching this video, then you will definitely know how you can build your own backend using Ktor. So that is a Kotlin backend, which I just like the most from all backends because I'm just so familiar with Kotlin, as you probably are as well. Then you will learn a lot about WebSockets, so that is just used for this real-time communication between different devices, between an Android device and a backend server, and you will learn a lot about how you can actually take the server and deploy it, so you can make it just available to anyone and you can actually play it with your friends instead of just in your local network. And of course you will learn a lot about Jetpack Compose to build something like this custom grid here. And yeah, just to give you a quick demo of how this game works, I have my two devices here, and if I open the app on my other device, where the first device is currently waiting for player X, then you will notice now it says next is X, so player X actually has to play. And if we then click there, you can see player X actually made their turn. Now next is O. Now we need to click here, obviously, which is the other player, so we could say, okay, let's make it here. Then you can see it will appear in real time on the other device as well. Now we can make our turn here again. Then player O, let's say here, player X, I don't know. So yeah, let's say we actually win. So now player X is at turn again. So we go in here and then we can see player X actually won. Then after 5 seconds, the game will simply restart. And now we can, just play another round here of this game. And this will of course work online, so you don't need to have both your devices next to each other. You can play this with your friends who sit in another country. So all this will be stuff you will learn in this video. And I know this is a long video, but I can really just recommend to really watch this till the end, because these long videos are the ones that teach you real development. Because here you build something that actually does something, that is actually fun to play, and that has an actual use. And like these 10-minute tutorials are great to learn just a simple concept, but these long videos really dive deep into specific topics, into building an actual app, and also how to connect it with a backend. We can deploy the backend to make something really functional. And also, just watching a tutorial or such a course is not enough. I would really recommend that at the end of this, you extend this app. And I will actually give you a homework after this. So just a recommendation, what you could do to extend this, to improve this app, so you can also practice on your own after this. And before we actually jump into coding, there is one more thing. This video is actually sponsored by Hostinger. You know, I don't often have sponsored video content on my channel, but when I do, you can be sure that I can fully stand behind that. And that is the case for Hostinger, who already sponsored 2 other videos on my channel in which we also built Ktor servers together with an Android app. And right now, since it's Black Friday again, it's this time of the year again, they have an amazing offer where you can get a web hosting plan for just $249 a month for 4 years. So this is a really affordable hosting plan. So you will get a free domain with this, you get unlimited traffic, you will get SSL certificates. And what I like the most is that they actually have 24/7 support. Like, we all know this, when we have a problem, then the support hotline or the support email contact is not available at that time. So it might be midnight or it might be Sunday, but here you will really get that 24/7 support, which I think is really important for web hosting. So with this offer, you will really get everything you need to build a solid website. Here you can click claim deal, add to cart, and you can actually save an additional few bucks here by using a discount code, by scrolling down and clicking on have a coupon code. And here you need to enter Philipp 7. So if you apply this, then you will get an additional discount here on this already quite affordable price. However, if you actually want to follow through this video and deploy your Ktor backend, which we'll build here, so you can play this game with your friends and not just in localhost, then we are not interested in this shared hosting. Instead, we want to go back and go up to VPS. VPS stands for Virtual Private Server, and that's basically just a remote Linux machine which we can control, where we have root privileges, and that is what we will need to actually run our Ktor instance on. So in that case, we would need to simply go to VPS, click on Start Now, and here we have different options depending on how big and how many users we actually, how many users our app actually has. But we will get to this later. So we will be totally fine with this VPS2 option. You can also choose this one if you're just caring about testing this app, but as soon as you have an actual user base, I would recommend at least this one. But we will get to setting this up later in this video when we actually build something that we can deploy. Before that, let's actually jump to another website where we can set up our Ktor project. And that website is start.ktor.io because if we want to create a Ktor project, we need to do this via this website. If you have IntelliJ Ultimate, which some people might have, then you can also do this directly within Android Studio, within IntelliJ. But if you don't have this, what most of you will probably not have, then we need to do this with this website. And here we first of all need to enter the name of our project. Let's say Ktor, or let's just say Tic Tac Toe. And we can adjust the project settings here a little bit. And the website, let's change this in my case to PL Coding. Change this to whatever you want. We can choose the Ktor version. We can change the engine, and we can change the configuration. Here we want to choose HOCON file, so that's just more like a JSON style configuration, you can say. Doesn't make a big difference, but I'm just used to this, so let's pick that. And we want to add plugins. So a plugin in terms of Ktor is just something, just a certain feature a backend should have. You can see this could be authentication if you were to implement that. We don't have this here, but this could be sessions, this could be routing. We need this, so we click add. That just means that we can define routes where our app can connect to. We want to make sure that we have content negotiation, which will make sure that we can actually parse JSON data in this on this backend. We want to make sure that we have call logging, so whenever a client, so our app makes a call to our backend, we will see a log message, basically for which route that was and things like that. And if we scroll down, we want to make sure that we have Kotlin X serialization. That will just be the JSON library we will use to parse to and from JSON. And most importantly, WebSockets. WebSockets will be needed to actually handle the real-time traffic, the real-time communication between our backend and our app, because as soon as we actually click in a tic-tac-toe field, we of course want to send that information immediately to all other devices, in this case just to the single other player's device. And if that's done, we can click Generate Project, which will simply download a zip file for us, which we now need to open and extract, and then open the extracted folder in IntelliJ. So please do that, extract it in IntelliJ. You can simply click open, select the folder, and then I'll see you back in IntelliJ. So here I am in IntelliJ. I opened this project that I just downloaded. We can close this tab here. Gradle sync was successful. That looks good. And then let's explore this project structure a little bit before we actually write our first line of code. You can see it looks very similar as an Android project. We have Gradle. In this case, it's the Kotlin version of Gradle. If we open our build.gradle file, then we just have our basic configuration here. We will put our dependencies in here, and we already have some of the default dependencies. You can see WebSockets was added, for example, because we included that feature on the start.ktor.io website, and things like content negotiation, Kotlin serialization, all that stuff. We don't need to worry about this. We can be sure that we have what we need here. The interesting part is now in the source directory, main, Kotlin, and here we have our application KT class, file rather. So here we have our main function, which will be obviously called when we launch this app, and it will call our application module behind the scenes. It's still indexing here, which is why the highlighting doesn't work. Doesn't matter. Here we just configure everything, all of our plugins, all of our features in Ktor. And if we take a look in these functions, for example, configure sockets, then you can see we get in here in another file that was already created for us, with some default code, default config here. We actually don't need this, but in case you want to find out how you can actually use these plugins, these features in Ktor, then it's quite helpful if they actually already add some default code for you. So in this case, here we install this WebSockets feature, we configure it. For example, we configure a ping period to find out if a client is still available, or we configure a timeout and things like that. Then here we have a routing block in which we have a WebSocket block to actually define a route where we can connect to for this real-time traffic. So this will essentially just be an HTTP request that is done once by the client, and after that was successful, the client and server will then just have an ongoing connection where both parties can send data to each other at any time. But we will get more in detail into this when we actually get to writing the code for our tic-tac-toe logic. Let's remove this routing block for now. Actually, not just for now, we will remove it and take a look in our plugins folder. Here we also want to take a look at monitoring. This is where our call logging feature is set up, so how our logs will look like for the client requests. We have our routing file. Here we just have a very basic sample route which will respond with hello world. We can also get rid of this. Let's just get rid of this get request that was specified here. And we can take a look in the serialization file in which we set up Kotlin X serialization, where we can also get rid of this routing block here. We don't need this. We just want to make sure that we have this install content negotiation block with the JSON function set up. And what's interesting before we start with this is our resources file, where we see our application config. So that's just some basic server config, most importantly for our port. So here we can specify which port our server is running on. Let's actually go to application and run this for the first time by clicking on this little play symbol, clicking run application, and then it will build this and hopefully everything will go fine. You can see it's now running and it does not crash. Otherwise you would see an error. Okay, it does crash. Address already in use. That is a common crash because there is already a program running on my machine here that is using this exact port. So if you see this as well, you don't have to see this. If you don't have a program running on that port, you won't see this. But if you do, then you can simply change the port in your application config file for development. For example, to 8081. Relaunch this. And then if there is no program running on that port, we should not be getting that error, as you can see. So that's it for the IntelliJ Ktor round trip. Let's actually jump into coding and get to the exciting part by starting to create a little package for models. So in our root package, we want to create a models package. And in here we will put, basically our whole game's logic. On the one hand, we want to represent the current state of our game in one single data class. And then we will keep on taking that instance of that data class and send it as a serialized JSON to our clients so they can also just update their corresponding local state. You will see how this works. So we just create a new file in the models package called game state, and we want to make sure that's a data class. In here, we want to annotate this with serializable, since we want to be able to parse this to and from JSON. And if we use Kotlin X serialization, we need to annotate these classes with serializable. So now we need to think about what really belongs to the game state. So what is really the state and what do the clients need to know about the current state of our game? First of all, they need to know which player is currently at the turn. So who is next? So val player at turn. And I will represent these players here by a simple character, which will be an X if it's player X and an O if it's player O, and which will be null if there is no player at turn right now. So we set this to null initially, or we can actually also set this directly to X. So we just say X always starts. Well, then we of course also need the information which kind of sign is on which field. So how our field really looks like. And we can do this with a two-dimensional array. So val field is an array of characters, of nullable characters. And we can then fill this field with either X's, O's, or nulls if there is no player who made the turn yet at that field. And we can then also create a little helper function which will create an empty field for us, so you just get a little bit of an understanding of how that will look like. So right here we could say function empty field, which will then return an array of nullable characters. We can say that returns an array of, and here we will put in 3 array ofs as well, which we initialize with null values. So just like this. That is our simple tic-tac-toe field, where each field is free, and if player X, for example, would now set the X in the middle position, we would replace this with an X here. And that is how we will represent the game state. We can then assign this empty field to our array by default and then go on. What else do we need? We need the information who is the winning player, if there is a winning player. So val winning player is also a character, and if there is no winning player yet, this will simply be null. So if this is not null, we can be sure there is a winning player and it is set to either X or O. We then also need the information whether the board is actually full. So then it would be a draw. So if there is no winner but the board is full, we need to make sure that we actually relaunch the game because there is no other turn to be made. And the last kind of value we need in this game state are the connected players. So we just know when everybody connected and when we can start the game, which will be a list of characters and set to an empty list by default. And you can also see that we get a little warning here because IntelliJ wants us to generate some equals and hashcode functions because that's not done by default for this array field, for this two-dimensional array. So we can just press Alt-Enter and click generate equals and hashcode by considering all of our other fields, clicking next, clicking finish, and then it will generate some cryptic functions for us, just to make sure that if we compare two game state objects, that we really get the same behavior as we would have with a data class that does not contain such a field. Cool, and that's already it for our game state. We will have the exact same class client side, since we will then be simply updating this game state server side, and then whenever this was updated, we will put it into JSON format and send that JSON string to our clients, which will deserialize it and then update their local state. What else do we need? Well, we of course also need to have some kind of way for the clients to tell our server, this is where I made my turn. And that is what we'll make with another model. So in our models package, we will also have a make turn class, which will be a data class. And with this class, we will simply be able to tell the server at which position the client made their turn. So val x and val y. And we also make that as serializable. And that's already it for this class. So in this case, the client would create this class, would serialize that into a JSON string and send that to the server, which would then simply update the game state here. Cool. So now that we actually have our states and our actions that the clients can actually perform, the next thing is that we implement our actual game's logic. So the core of our application, you can say. And this should, of course, be implemented server-side because client-side, these clients could theoretically manipulate the data they send and then manipulate the game's logic. So things like that should really always be done server-side because the server can really validate in the way they want to, in the way it should be validated. So here in models, we will also create another class, which is called Tic Tac game, which will represent a simple game here in our app. And here we will really be spending most of our time, at least server-side. And first of all, we want to have a private val for our state, which will represent our game state. And this won't be very different from what we know from Android. We will use a mutable state flow here, which we initialize with an empty game state. Here we don't need this public version of this state because we don't really need to access this outside of this class, so we're just fine with this state field. But what we also need is a private val player sockets. So that is now WebSocket specific, but if a player connects to our WebSocket route, then we kind of need to store or keep a reference to the connection between client and server. And this connection is in the end called a WebSocket session. And we can use this connection to just send data to a specific client at any time. And we of course need to keep track of these as long as a certain player is connected to our game. And we will do this with a so-called concurrent hash map, which will map from characters to WebSocket sessions. Concurrent hash map because we just want to make sure that we can access this hash map from different threads. That's a very likely thing that is going to happen on a server environment, that we access things like that from different threads. So we want to make sure that there won't be any race conditions. And concurrent hash map makes sure that that's the case. And then we say, okay, player sockets for player X is actually this socket connection. And for player O might be a different WebSocket connection. And then we can easily use this map to send specific data to a specific client. And for now, we also want to have a private val game scope, which will just be a coroutine scope running in supervisor job plus dispatchers.io. So that will just be our coroutine scope we will use to launch coroutines inside of this class, which we can then also use to cancel certain coroutines very easily. Cool, so what do we actually start with to write here? I want to start to create a function to connect a player. So as soon as one of our clients actually makes the request to our WebSocket route, we want to call this function with the WebSocket session that was actually passed to this route. And then we will return a nullable character here for whoever actually just connected. And then we first of all want to check, okay, is there actually already a player X in our room? Because the logic I will choose here is that the first player who will connect will always be player X, and the second one who connects will always be player O. So we first of all want to check, is there already player X? So is player X, and we can say, okay, that is equal to stated value, connected players, and if that has any values where it is equal to X. We can then check if that is player X. And if that is the case, we want to set the player equal to, well, let's just do it on one line. We want to set the player to O. So if we already have player X who's connected, and else we set it to X. Then we can update our state, our game state. So state.update. And first of all, we want to check if there is already a socket for this player. So if player sockets that contains key, and the key will be player, and actually want to check if that's not the case. So if there is no key yet for this player, so if there's no existing connection, no existing session, we want to assign such a session. So in that case, we want to say player sockets add the key of player is equal to the session we passed here. And what we also want to check before is if there is actually already a player connected, because right now we could potentially connect 3 players into our room. If the third player would connect, this line would simply return true. So we would jump into this else block and make the third player X again, which doesn't work in Tic-Tac-Toe, of course. So we first of all want to check if the state value connected player contains the player already. If that's the case, we want to return null here. So then we will just close the connection from where we will call this function. Cool. Then after this if statement here, we just want to update our state so we can access the existing game state using id.copy, and here we can say connected players is equal to id connected players plus our new player. And then after this state update block, we can then return our player that actually connected. And that's already it for our connect player function, which will work just fine. And if we have a connect player function, we also want to have a disconnect player function, which will be next. So right here, we want to have a function disconnect player. The player will be passed in form of a character again. And in here, we just want to say player sockets that remove, and we want to remove the key player. And we also then want to update our state, so state.update. And here we can just say id.copy and connected players is equal to id.connected players minus our player. So we just remove the player that is connected from our existing list. And that's it for the disconnect function. That's much simpler than this connect function here. Now, next, we want to have a function to send something to all players. And specifically, we want to send our game state to all players. So let's create something called broadcast. And we want to broadcast our game state. And the way this will work is we will simply use our player sockets, and we can use these WebSocket sessions to send something to those specific sockets. So we can say player sockets that values for each. Here we get a reference to the socket, and then we can say socket.send, and we need to send a so-called frame. So a frame could either be something text-based, which we will use here. So we will send JSON data, or a frame could be something, could be bytes. So if we were to send a file or so. So in here, we want to construct our frame, or we can also directly pass our string, which we'll actually do here. And to simply parse our game state to JSON, we use a JSON.encode to string, and we simply pass the game state. And we get an error here because that's a suspend function, so we also need to make broadcast a suspend function. And then here in our init function, so when we create this class, we just want to make sure that we use our state, and we can say dot on each. So on each emission, we simply want to call this broadcast function. And we can then say launch in our game scope. So what this line will do is it will say on each emission, so whenever this state changes, we call our broadcast function with that corresponding state. So you can see we pass the state to this function anytime the state changes, and we will broadcast it to all players to just make sure nobody will miss any updates. We launch this in our game scope, which will then just make sure, that we have a coroutine where this broadcast function can run in. Cool, but that's not it yet. We need to write a little bit of more code for this class. The next function we will write is a function called finish_turn. So whenever a player actually makes a turn, we will call this function for a specific player and for a specific position where the player actually made that turn. So in here, we first of all want to make some assertions that we don't really finish a turn if we don't want to finish a turn. So first of all, if state.value.field at the index of y and x, if that is not equal to null, so that means there is already someone who made the turn at that position, then we of course want to skip this. So we then don't want to make another cross or another circle on that specific field. Or if state value winning player is not equal to null, that means we have a winning player, then we don't want players to be able to make more turns. So in those cases, we simply want to say return here. And we also want to check if state value player at turn is not equal to the player who actually makes this turn and finishes this turn, then we also want to return, because only the player who is actually at turn should be able to finish their turn. So then we can say we get the current player, which is state value player at turn, and we then say state.update. And in here we first of all want to create the new field. So now that the player made their turn at this specific field, we want to, of course, update our field state. So we say val new field is equal to it.field.also, and here we get a reference to that field. And we want to say field at the index of y and x is equal to our current player. So we just update the specific field to our player who made that turn and then save that in new field. Then we also want to check if the board is full. So val is board full is equal to new field.all. So we check for all fields. So we would get a reference to an array of characters. So basically this will be executed for every single row. And then for every single row we want to check all again and check if it is not equal to null. So if all fields in our new field are not null, that means there is no empty field anymore, so our board is full. And if that's the case, so if the board is full, we want to say start new round delayed. That is a function we will create, which will simply start a new round after 5 seconds. And apart from that, we want to update our state. So we update it to it copy. We want to say the player at turn is now if current player is equal to x, then the new player at turn will be O, and else it will be simply x. Then the field will be updated to our new field. IsBoard full will be updated to our isBoard full boolean, and our winning player is, well, here we also need a function to determine if there is a winning player, and if so, who is the winning player. And I will call this function getWinningPlayer. And if there is a winning player, we can say .let, or rather also, and also call our function start new round delayed, because if there is a winner, we also want to start a new round after 5 seconds. So those two functions are functions we now also need to create in this class, but I think these are the last two that we need to make our, at least our game logic work. And then only the connection stuff with our WebSockets is missing. So let's actually go here on this function, press Alt Enter and create that function, start new round delayed. And all we really want to do here is we want to remove this. And we want to scroll up and create a reference for this coroutine job, which we'll use to delay this, starting this new round. So we can say private var delay game job or so, which will be a job nullable and null by default. And then down here, we first of all want to say, okay, we want to cancel this job. So if there's an ongoing job, we want to cancel it. And then we assign a new job to it using gamescope.launch. Here we want to say we delay this for 5 seconds. And then after these 5 seconds, we want to update our state. So state.update, and then here we say it.copy, well, who's the player at turn. We want to start with X, so X will always start the rounds. The field will be game state dot empty field. The winning player will be null, is board full, will be false, and the connected players will simply remain because nobody disconnected. So now we already have this function, and the last function we need is get winning players. We can also alt enter on that and create that function. And this function will return a character, a nullable character, which will be exactly the player who won, or null if nobody won. And I will say that I will actually paste this code because it's super repetitive. I will explain what happens there, but as you can see, if I paste this, it is very unreadable, but that's basically how we evaluate if a tic-tac-toe game is won by a specific player. So for example, we check if field 00 is not equal to null, and then if 00 and 01 is the same kind of player, and if 01 and 02 is the same player. So this would correspond, let me think, probably to the first row. So the first field, this is the second field, and this is comparing the second field with the third field. So if this condition is true, we know that the first row of our game is filled with the same player. In that case, whoever is on field 00 will be the winner, and so on. So we basically just go through all the different combinations we could have with a tic-tac-toe game to have an active winner, and then just return that here, whoever is at that specific field. If all these conditions fail, we simply return null, so then there won't be any winner. And of course, you don't need to type this by hand. You will find all the code for this project down in this video's description, so you can also just copy and paste this function here, because I don't really see a reason in typing this off. There's not really a lot of value in that. Okay, so the last real thing we need to do here for our backend is the route where our clients can connect to use or to communicate via WebSockets. And let's just do this in our root package here, create a new file called socket route, make that a file. And the way this will work in Ktor is we will simply make this an extension function of route. So we import this and say, let's just call this socket, for example. And then in here, we will actually get a reference to our game, so our tic-tac-toe game. And then we can say, okay, we have our route here. We specify the path where our clients will connect to, which I will just set to /play, where they can play the game. And then we say WebSocket. You already saw the syntax in the pre-configured function from Ktor, and we just use this to create a WebSocket connectable route, you can say. And in here you can also see that we get a reference to a default WebSocket server session, and that is exactly what we need to send something to our clients and to receive something from them. So if we say this dot incoming, then this is a received channel of frames. So as soon as a client sends something, this receive channel will be triggered. And if we want to send something to our clients, we will use this outgoing instead. You can see this is a send channel, so we can send something into that channel. For example, our game state updates. So we first of all want to get a reference to the player that connected, and that will be equal to game.connect player. And the session that we connect to, or that the player connected with, is simply this. And if that player is equal to null, that means that there are already two players connected. And then we simply want to close this connection. So we want to avoid, or just make sure that not 3 or more players can connect to a single game. You can pass a close reason so the client knows why the session was closed. And we can say close reason codes that cannot accept, for example. And we can say 2 players already connected or so. And we return out of this WebSocket function. If that's not the case, we want to have a try, catch, finally block. So we just want to catch exceptions here. And we want to have a finally block. And the way this will work is we will now go inside of this try block and we say incoming dot consume each, which will now be triggered for every single piece of data our client sends. Here we get a reference to this frame. And such a frame will now just contain, for example, a JSON string with the information where a player made their turn. And if that frame is a text frame, so it contains just text, then that's a frame where we are interested in. And we basically now want to extract the action that the player wants to perform. So In this specific case here, because we have a super simple game, there is only one action that could come from a client, which is to make a new turn. But usually in more complex apps, you would have more different types of actions. For example, if you would want to also allow players to manually restart a new round and don't automatically do this after 5 seconds, then you need some kind of button in the client app where the clients can then click on and then also need to send some kind of action. So there are different types of actions we potentially would want to parse from. And that is why I will create a little help function here to extract a certain action. So here we pass the JSON message that arrived from our client, and in this case we will just return a make turn. But if you would have multiple actions, you could adjust this function a little bit to support maybe like a generic type and parse it based on whatever that message is. And the format of our messages will be something like this. So we first of all will specify the type of action. So we want to make a turn, then a hashtag, and after that we have our JSON data. So in this format, we will parse our actions. So we first of all want to check what that type actually is. And based on the type, we will then parse this JSON body. So first of all, the type is message.substring before that hashtag. So just the string before a hashtag. And then we have the actual body, which is message substring after our hashtag. And then we can return if the type is equal to make turn. Then we want to simply take our body and say JSON decode from string, this one here, and we want to decode our body, import JSON, and else we just return make turn with, let's say, -1, just an invalid version. This will never happen because we only make sure to send these make turn actions from our client. Then we can scroll up, go in here and say val action is equal to extract action, and the message is frame.read text. That is how we get a reference to the text that was sent from the client to the server. And then we can say game.finish turn, because when that action is received, we want to finish the turn for that player. The player is this, and action y is action.x and action.y. Just like this. And that's already it, what we need to do in this incoming consume each block here. But what actually happens if the client disconnects? How do we detect this here server side? In this case, this try block will actually throw an exception because this channel was closed. Then in here, we simply want to print the stack trace. And finally, so in all cases, when this try block finishes, we just want to make sure that we disconnect that player that previously connected. And that's pretty much it, what we need to make our game work. Right now, this function is unused. We need to set this up. We need to call it explicitly to tell our server that we have this route to just set it up like that. And we do this in routing. So we open our routing file, and in this routing block, we can simply call our socket route. And we pass our game instance, which we can also pass as a parameter here, just to follow dependency injection a little bit. And then where we call this configure routing function, which is in our application KT file, here we can create our instance of our game. So just say that's equal to a Tic Tac game and pass it down here. And then in our game, whenever our state actually changes, we just make sure to broadcast that new state to all of our clients that are actually connected to the game. So all of our player sockets. And that's it for the server for now. We will later actually get back here when we want to deploy this to a hosting or VPS instance, because then we also need to set up a little bit stuff in our Gradle file. But for now we are fine and we can test this locally the way we set it up right now. So let's actually just run this once and hope there is no error. And I also hope I didn't make any other kinds of errors here, which we'll probably see when we play this for the first time, when we also build the Android app. But you can see our server just runs fine and there are no errors, there are no exceptions, which looks good. So I would say and suggest that we now start building the Android part of this project, which is also quite cool and exciting. So here I am in an empty Android Studio project, and all I really already set up are the dependencies and Gradle configuration. You will find the initial source code down below in this video's description on my GitHub. So let me just quickly show you what I already set up here. First of all, these two class paths here for the Hilt Gradle plugin. So we'll be using Dagger Hilt for dependency injection. And we will also be using the Kotlin serialization library for JSON parsing. And then in build.gradle app, I added these 3 plugins. This one is also used for Dagger. This is used for Dagger. This is serialization again. And if we scroll down, here we have our Dagger dependencies. We have Dagger Navigation Compose, which we actually don't need here, by the way. And we also have the view model compose dependency to get a reference to view models in Jetpack Compose. And what's important is Ktor. So Ktor is also a client-side library, which is comparable to something like OKHTTP. So basically whatever drives retrofit, or you could also compare it to retrofit, just a different Kotlin implemented HTTP client we can use to connect to a WebSocket route. With retrofit, we can't do that, which is why we use Ktor here. And for that, we also have the core dependency, CIO, which is needed for WebSockets, which is also needed for WebSockets. We have logging and Kotlin serialization here to also be able to parse stuff to JSON. Let's click synchronize now. And in our Android manifest, the only thing I added is internet permission because I like to forget that. So if you have that, I would say we go back to our backend and actually just copy over 2 classes that we also need client-side. And that is on the one hand GameState and MakeTurn, because these classes are of course used to communicate. And therefore we need these in both these projects. So in our root package, let's create a package for data. And here I will be only using presentation and data packages, so we won't be using domain or so because I feel like that's very unnecessary for a rather small project. And in data, I will paste these 2 classes. So on the one hand, we have GameState here, which looks exactly the same as server-side. And if we take a look here to MakeTurn, then this will also just look like server-side. I'm not sure why the syntax highlighting doesn't work, but it seems like it's still analyzing. So I have no idea what currently happens. And also if I type GameState here, it doesn't recognize that. So it seems like I successfully broke my Android Studio, so I will need to invalidate the caches and restart this. So I'll see you right after that. So I am back and now it seems to work. So my GameState is recognized. I need to just update my packages here. Also probably in MakeTurn. Let's do this, Alt-Enter and update that. And then I could access it here, I assume. Yes. So what do we now want to start with here client side? Client side, I think we actually need to write less code since no, actually not less code. The drawing code is quite large, but it's a lot of repetitive code that we will write there to draw our tic-tac-toe canvas. We first of all want to start with the fun part, and that is how we interact with our backend. So in our data package, I want to create an interface, a little abstraction for a real-time messaging client. That's at least how I call this abstraction for our WebSocket client. Let me add that to Git. And here we will have 3 functions that a WebSocket client actually needs. On the one hand, we will have a function getGameStateStream. This function will return a flow of type GameState. So whenever there is a new GameState coming in from the server, this flow will essentially trigger, and then we can also update our local state. Then we want to have a suspend function, sendAction, and the action in this case is just MakeTurn. I talked about these different actions you could potentially have server-side, but here in this case it's just MakeTurn, and yeah, we can send this from our client to the server as well, of course. And finally, we will have a suspend function to close the connection. So in case the user just leaves the app, we want to call this. Then in data, we want to create an implementation of this real-time messaging client, which will be called Ktor real-time messaging client. So the Ktor specific implementation of this. We will implement this interface, and we also want to make sure that we have our client here in the constructor, which will be an HTTP client. You can see this comes from Ktor, which will then provide from the outside. Then in here, we need a reference for the current connection, for the current session. I also talked about that server side. It's very similar client side here. So that's just a WebSocket session. Nullable and null by default since we didn't connect yet. But then we can press Ctrl I and implement all these functions. And here for our get game state stream function, which is probably the most important function, since here we will be getting all of our game state updates. Here we want to return a flow. So in this flow builder, we can now kind of take our HTTP client, connect to our WebSocket route, and then listen to all these events that are coming in, parse them to game state objects since they're obviously coming in as JSON, and then just trigger this flow that we return here. So later on in our view model, we can then update our local state, so our Compose UI will be redrawn. So in here, we want to first of all set our session equal to our client.WebSocket session, which will return a default client WebSocket server session, WebSocket session without server. And in here, in this builder, we can set the URL for this. So we now need to specify the URL where we want to connect to for this WebSocket connection. And that is simply WS, so it's just a protocol, just like HTTP, just that this stands for WebSocket. And the IP address, in my case, is still a local one, of course, since we haven't deployed yet, which is this one. In case you don't know how to get this, you would need to go to your Wi-Fi settings, and then it will actually show your IP address. Or if you're using Windows, you need to go to your CMD, type in ipconfig, and then it will also print your local IP address, which you can then connect to, so you could play the game with anyone who's connected to your Wi-Fi. We also want to connect to the play route, which we configured on our server. Then, after that is done, you can see that's a suspending function, which will suspend our flow. After that is done, we can use our session to listen to events, to incoming messages. So we will be getting all these game states by saying session dot, or actually let's assume this is not null here, because at no point this will be null. We can say session dot incoming, which will be the receive channel we get here with all incoming game state messages. And we say receive as flow. Is it actually consume as flow? Consume as flow. So that way we get a flow of type frame. And as you know, a frame can either be like a file or it could be some text. In our case, it'll just be text. And now we want to transform these frames, because obviously a frame is not what we want to emit here in our flow. No, we want to emit game states. So we first of all want to filter is instance. We only want to receive text frames. We don't care about any other types of frames. So we use this function, and then we can say map not null JSON dot decode from string. Use this string function here. And well, which string do we want to decode? We want to decode it, which is our text frame, dot retext. And I think we need to also specify, yes, we also need to specify the return value of that JSON function, since otherwise we will get any object. So we need to say those are all game state objects. And that way we have a flow, as you can see, of type game states, which will trigger every time there is a new message coming in from the server. It will automatically map that to an actual game state object by using our JSON decode from string function. And now we want to take all these game states and send these into this outer flow. So we can do this with emit all, and we simply pass in our game states. And now we have a function that goes over 10 lines. And all it does is already, it listens to WebSocket messages, to real-time messages. It contains all the mapping code to map these to actual game state objects client-side, and that will work. So it's really not a lot of code here with Ktor. I really like the library. Let's go on with send action. That's even less code. So in here, we just want to get a reference to our session and get a reference to the outgoing channel. So that's a send channel. And here we can call the send function to send a frame. This time it will be a text frame again. And the text that we want to send in here, or we actually could also just send the string, I think. No, here that doesn't work. Frame.text. And the string we want to send is make turn, since we only have that action, then hashtag followed by our actual action parsed to JSON. So we want to say JSON decode, no, actually encode to string, encode to string, this one here, and pass in our action. Just like that. And then that is already the function to send something to our server. And finally, the function to close our connection will simply be session.close. And then we say session is equal to null again. And boom, we have a working WebSocket client for our client to connect to our server, to communicate with our server in real time. And now we only need to use it to update our local state and draw the corresponding game UI. But you see, since we obviously implemented all the game logic on our server, the client doesn't need to implement that code. And that's, of course, on the one hand, a lot better because the server can do the validation, which is much more secure. But on the other hand, let's say you would have an iOS and an Android app, which both work with your single server, then you would only need to implement that logic at a single place on your server and not in both your app's code bases. I hope that makes sense. Let's go to our root package and create a presentation package. And in there, we want to create our tic-tac-toe view model. Like this. That will just be a normal Android view model. We annotate it with hilt view model, since we want to be able to inject dependencies in here. We use the inject constructor like this, import inject. And which dependency do we need here? Well, we need a private val client, which is a real-time messaging client. So in here in the view model, we can now use this client to listen to game state updates and also send actions to our server. So what kind of states do we actually need here? In addition to our game state, we also need some client specific states that the server doesn't care about. And that is on the one hand, that is connecting. So we can show a progress bar. That is a mutable state flow, false initially. And we also have a public version of that like this. And we want to have a private val connection error, or rather, let's call it show connection error. So if there is a connection error, we will show it. Also mutable state flow of false. Show connection error is show connection error.as state flow to just expose the immutable version of that state flow. Cool. How do we now get in our game state flow here? We will do this by saying val state is equal to client dot get game state stream. And here we can say that on start. So as soon as we start collecting the emissions from that flow, we will actually call this on start function. And in here, we simply want to say is connecting is not true. So now we start to connect. And then we say on each is connecting value is false. So on each will just be called on each emission. And yeah, as soon as there is an emission, we obviously want to say, okay, we stop connecting. So then we just know that this function actually finished, which is suspending. So as soon as we reach this code, then the on each will be triggered. And we know we successfully connected. Then we want to say catch, because our Ktor client could potentially throw an exception. For example, if we can't connect, if the server is not reachable, we can catch these exceptions with a catch block by catching our throwable here. And we can then say our show connection error, that value is our throwable is a connect exception. So if our throwable is a connect exception, we know we couldn't connect, and then we want to show the error, else we don't. We can also put this on a single line, I think. Like this. And last but not least, we want to say that state in view model scope, sharing started while subscribed, and I will explain this, of course, after I tap this line, and game state, just a default state. So what happens here is we effectively, with this catch function or all these other transformation functions, we just get a normal flow reference. However, in view models, we usually want to use state flows because we want to reflect UI state. We want to cache the latest value, show that also on screen rotations, and we do this with state in. So with state in, we convert a normal flow into a state flow. We use the view model scope to launch that flow. We use sharing started while subscribed. So all this stuff will only be executed if there is actually an active subscriber. So if the UI for this screen is actually visible and listens to this state here. And this is just the default state for our game. And now the only real function we need in this view model is if the user makes a turn, because then we need to send that to our server. And all the other things are already reflected by the state which we get from our server. So we can say function finish turn, And we can make the turn at a specific X and Y position of our tic-tac-toe canvas. And let's also do this validation we did server side, also client side. So if state value field at our Y and X index is not null, so that means that field is not free, or if state value winning player is not null, so if there is already a player who won, then we simply want to return. So we don't even need to send any kind of data here. Else, we want to send that action to our server. So we say viewModelScope.launch, and we use our client to send an action, and the action is make turn at a specific position, which is X and Y here. And last but not least for this view model, down here in onCleared, so when the user leaves the screen, when the screen is popped from the backstack, then this view model is cleared, and then we just want to make sure that we close our connection. So we just say client.close. And you can see how light our view model now is. With this view model, we make sure that we map our whole game state, and we make sure that we show connection errors, that we show a connection progress bar. Now, all that's really missing is using creating our UI, drawing all these things based on these states that we have here. So in presentation, we want to create a new package. Well, let's not create a package. Let's just create a composable here called tic-tac-toe field. So how will we create this rather complex composable? Because it's quite custom, of course, to draw this field for our tic-tac-toe game. We will effectively use a canvas for this. So with a canvas, we have full freedom when it comes to drawing shapes and lines on our screen, and that is exactly what we will use. So there will be a lot of math involved now. We will basically specify relative coordinates from where we actually want to draw a line to where we want to draw a circle, maybe if we click on a field and things like that. Let's go through this step by step, and then it will be all clear. First of all, composable tic-tac-toe field, and that will need a bunch of parameters. On the one hand, it will need the game state that we want to show here in our field. Then we want to be able to pass a modifier from compose, like this. We want to be able to choose a color for player X, which is a color equal to color dot, let's say green by default. We have a player, player O color, which is color.red, let's say. And we also want to have a function on tab in field, which will be triggered if the user taps in a certain field. It will give us the X and the Y position of that field. And this won't be the actual pixel coordinates. No, this will actually be like 0, 0 for the field in the top left. It will be 0, 1 for the field in the middle, like the middle field of the first row, and so on. And then in here, we are going to create a canvas. Here for this canvas, we're going to pass our modifier, and on draw is very important, since that's where we get reference to this draw scope. We can actually also get rid of this and just specify it like this, so we have one less indentation. So with this draw scope, we get access to a bunch of functions like draw oval, draw line, draw arc. We get a size of the canvas. So all very relevant information that we need to be able to draw something and to draw shapes on our screen. So how will we do this and how will we start? First of all, we would actually like to start just drawing the basic game field, like with our horizontal and vertical lines. If we open our emulator and open the tic-tac-toe field here, you can see we first of all want to draw these lines and these lines before we think about drawing actually the X and O's here at the corresponding positions. So how will we draw these lines? I will actually make a little helper function here for a lot of these things. First of all, that will be a private function that extends draw scope, and it is called a draw field. And in here we will now draw these 4 lines. So the first one will be the first vertical line, and we can say draw line. The color for this will be color.black. Then we need to specify a start offset, So an offset in terms of canvas is always just a position on the screen. And here we also work with pixel values, not with DP values. So we say offset at a certain X and Y position. So where do we want to start? We want to start right here. And since the size of our canvas can differ, we need to kind of calculate the relative size. It's basically at 33% based on the width of our canvas, where we want to start this in terms of X position. And the Y position would simply be 0. So what we can say is, we can say X is equal to size dot width. So size refers to the size of our canvas, this to the width of our canvas, whatever that is. And we multiply that with 1 divided by 3f. So just, multiply that with 1/3 to get the X position of our start offset for that line. The Y position will simply be 0. And now we also need to specify the end position, which is another offset. At this time, it's actually size.width multiplied with 2 divided by 3f. So we actually get to this X position here, which is 2/3 of our whole width. And then our Y will be simply 0 again. Then down here, we can say we actually have a stroke width, so how thick our line actually is. Let's say that is 3.dp.2 pixels. So we just say this line is 3 dp wide, and we can use this 2 pixels function here to convert that to pixels, since, as I said, canvas works with pixels. And we also want to set the cap to stroke cap.round. That will just make sure that these ends here are actually rounded and not straight. And I actually made a mistake here. This Y offset actually shouldn't be 0. It should be size.height, because we obviously want to draw from Y being equal to 0 to the whole height of our canvas. So this would be Y0, and this would be Y equal to size.height. And now we successfully drew our first vertical line, and we can also actually set up a little preview here so you actually see what happens. Tic Tac Toe field preview. Make that a preview. And now with Electric Eel, we finally got that real-time preview. And in here we can say Tic Tac Toe field. We assign the default game state. We could also change that a bit and not care about these values. So if we say the player turns X, that's fine. We can say the field is, let's say, an array of, let's say, X, null, null. Duplicate that twice, say null, just that we have some kind of sample value here, and we see that we actually can draw something like this. And let's also set this one to null, like the whole last row. Then the rest should actually be fine. So if we now open this split tab, build and refresh, we should be able to see nothing because we didn't call this function yet. But in the canvas, if we do this, like draw field, and in the preview composable, we also say that we want to show a background, true. Then we hopefully get to see our very first line that we are drawing on the screen. We probably also need to assign a size for our canvas. So we say modifier is modifier.size, 300 dp, for example, and it will reload. And oh, there's our line that does not look as I want, because yes, I confused this already with the second horizontal line. So this shouldn't be 2/3, it should be 1/3. And then you will see that the line will actually be a straight line just going down. And now let's get to the next line by copying this, pasting it here for the second vertical line. And here we just need to change this to 2/3, and the rest should be the same. As you can see, now we have our second line. We can then paste it for our first horizontal line. This time, these things are actually swapped. So here, this would be the Y value, and actually size.height, and X would be 0f. And here we swap this. So the size.width times 1/3 would be size.height times 1/3, and the X value will be size.width. It should be. Let's see if that looks good. Yes, that looks very good. We can then copy this again, paste it below. This will be the second horizontal line. And this time we again start at x being equal to 0, and we just change this to 2/3 here. And then we already have our tic-tac-toe field. As you can see, it will, does it update? I'm not sure if it already updated or if I'm missing something. Let's rebuild this here. Maybe there is an issue with the preview, which I wouldn't be surprised about. Yes, okay, it actually looks perfectly fine now. So now we have our helper function to create our very simple field. And now the next thing is that we also create these functions to draw an X and an O. So let's do this right here. Private function drawScope.drawX. And here we also want to be able to specify a color. We want to be able to specify the center of this X here. So basically, yeah, just the center offset. And we want to be able to specify the size of that X, which will be a normal size. And we set this equal to a size of, let's say, 50 dp 2 pixels and 50 dp 2 pixels. So that's just the default size. We could also make this relative based on the size of each cell, but I like to keep it at 50 pixels here for simplicity, 50 dp actually. So how will this work? How can we now make sure that we draw an X at the corresponding position that we passed here as the center? So we want to say draw line. Essentially, an X is just 2 lines drawn in the right way. The color will be our color. That's still very simple. But now it gets a little bit more difficult. We want to specify the start offset. The X value of the start offset will simply be our center.x. And here we now want to subtract half of our size's width. So if here's our center for the X, then our first line should actually start right here. So we want to subtract this amount of width, and that's exactly half of our width. So we can say minus size.width, size.width divided by 2f. And we do the same for y, so center.y minus size.height this time divided by 2f. And then we can also specify the end offset. This time it's center.x plus half of our size's width. And y will be center.y plus size.height divided by 2. And then again, we can set our stroke width to 3 dp pixels, and we can set the cap to stroke cap round. And that will be like the first kind of line for our X. We can now copy this, paste it below for the second one. The first X position will be the same as the X position for our first line, but the Y position will differ. Here we will actually add half of our height, and the end position for X will now be, it will also be the same, but here we will subtract our Y position, or we will subtract half of our height to get to the final Y position. So if we now just go ahead, go up here and say we want to draw an X, the color will be player X color, and the center will be offset. Let's say X is size.width times 1 divided by 6f, so 1/6, since that is the center of one field. And Y would also be size.height times 1 divided by 6f. Then we should hopefully see something. And yes, that's wrong. So it's again either an issue in the preview or in my function. Let me rebuild this very quickly. And if that seems to be an issue in the function, let's scroll down. Oh no, now it's actually correct. You can see the X is exactly where we want it. If we say we have 3/6, then the cross should actually be right in the middle, I think. So let's build and refresh. That's exactly the center of our screen. Yes, so that looks quite good. Let's now also do this for our O. So private function drawScope draw O. Pass a color, actually just the same type of values here. And then this time we don't need 2 draw calls. Instead, we only want to draw a circle. Color is color. Center is center. We can just pass this here. The radius is our size.width divided by 2. And the style is important here. We want to set stroke, so we just don't draw a filled circle, instead just a stroked circle. The width, again, is 3dp to pixels, and the rest can actually stay the same. So if we swap this draw x call with a draw o call, then we should be able to see, yes, a green circle here. So now we can actually draw all shapes that we really need here. Now all that's missing is that we are actually able to tap in a field, call this onTapInField function, and also be able to draw all these shapes at the specific position where they should be based on our field that's contained in our state. So what we'll do is, instead of this, we will say state.field for each indexed. Here we will get a reference to each, what is that, each y value. The players are not needed. And for each field, so this will now be done for each array in vertical direction, so in y direction. For each of these, we want to also have another loop, so we just loop over each field. We want to say state field at y dot for each indexed. This time we have x and our player at that position. So now we execute this for every single field in our state, and we want to decide whether we want to draw something at that position or not. And first of all, we can get the offset where we would want to draw something, if we want to draw something there, which is equal to, first of all, x times size.width times 1 divided by 3. And no worries, I will explain this right afterwards. And we add size.width divided by 6 on top of that. So that's probably the most complex part here. We basically try to find the field based on this x value where we want to draw this. So if x is, let's say, 0, then we're talking about this, about one of these first fields here. And we now want to get to this center position, to this x position here. So we multiply this x, which is 0 here, with size.width, so this whole thing will then stay 0. And we add size.width divided by 6 here, because we care about the center of each field. And since we have 3 fields, and all these 3 fields have a center, which we would kind of divide into 2 parts for each field, we need to add like half of each field's width on top of that, which is just 1/6 of our width. Very complex. I hope that gets clear. It's not easy to explain, but we basically want to do the same for our height. So size.height times 1/3 plus size.height divided by 6f. And you will see that this will work just like magic. So we can now check if the player is equal to x. We want to draw an x at that position with player x color. Else we want to, we're not at else yet. The center will be our offset. The size will remain. And you can already see, we see an x right there in our preview. And else, if the player is an O, we want to say draw O at, like with a color, player O color, and center will be offset. And now we should hopefully see our whole tic-tac-toe field state. Yes. So if we scroll down to our preview, then here is our game state, and that is exactly what is now reflected here in our field. So if we now swap this, for example, with an x, we should be able to see an x here. After this rebuild, maybe we need to rebuild manually. Yes, there we go. So now we effectively have the option to assign either an x or an O at any of these 9 positions here. So the last part is, if a player clicks somewhere in our field to find out which field they clicked in, and then call our callback function here with that corresponding x and y value. And if a player clicks in any field here, then we will actually get the result of that by using pointer input, passing true here because we never want to re-trigger this input. And in here we can say detect tab gestures, where we'll get an offset where the player basically clicked. And this offset will now contain pixel coordinates. However, we don't want to pass pixel coordinates here to our callback. Instead, we want to pass, for example, 0, 0 if the player clicks in the top left field. We want to pass 0, 1 if the player clicks in this field. So we kind of need to map this click offset to these coordinates for our two-dimensional array. And we do this by saying val x is equal to 3 times actually it dot x, so the x position of our click offset, to integer, and we divide this by our size.width. So since we have an integer division here, it will always round down, which is exactly what we want here. So let's say the click offset would be somewhere here at 20%. Then we would multiply that with 3, because we have 3 fields in our whole width. And then just divide this by our whole size's width to get to either 0, 1, or 2, depending on where the player clicked. And then we can do the same for y, replace this with y and this with height. And then we can say we call onTap in field with x and y. So I hope all this math stuff got somehow clear. If not, really don't worry. This is quite complex. And I also didn't just sit there and write this down as if this was like super simple. I also needed to experiment a bit with that and play around what does which, and but I prepared this code obviously, and I hope I could explain it somehow understandable. So now we want to go to main activity. Now we finished our tic-tac-toe field. And now we just want to call this and make sure that we observe the state from our view model and assign it to our tic-tac-toe field to reflect the game state. And I just noticed that we do need the dependency that I removed, the hilt one. Do I still have that here? No. So I need to paste this again, since we obviously use dependency injection with hilt in view models. So we need this navigation compose dependency. So we just synchronize this, add this dependency back. And in our main activity, we can first of all annotate this with Android point. And here we get a reference to our view model, which is equal to hilt view model. And the type of view model we have is a tic-tac-toe view model, of course. And then in here, we can listen to all of our different states we get from the view model. On the one hand, of course, most importantly, our game state, which is val state by view model dot state collect as state. So we get it as a compose state. We can alt enter to import this, then get the is connecting state by view model is connecting collect as state. And we can get the show connection error state by view model show connection error collect as state. Just like that. So first of all, if we should show that connection error, then we want to show a box with that specific error. So modifier fill max size. We make sure that the content alignment is center. And in here, we're just going to show a little text where the text is couldn't connect to the server. So, and we make sure that the style is equal to material theme that, what is it, typography error. Do we have an error text here? I'm not sure. Then let's at least just set the color. I think that is what I want to do. So color is material theme colors error. Yes. And we would also return here, since then we don't want to compose anything else. Other than that, if we don't want to show a connection error, so if there is no error, we want to have a box in which we will put in our different composables. On the one hand, we want to set a modifier here of modifier fill max size. We want to make sure that the content alignment is center. And in here, we will have a column. So this column will basically just contain this text here. It will contain, of course, our field. And in the bottom, we will also have a text when a specific player won. So what we're going to do is we're going to say modifier is modifier dot padding. Here we want to add some top padding of 32 dp, so the text is offset a little bit. And we want to say we align this column in the top center. And inside this column, we will check if state connected players contains our X, or rather if this does not contain that player, then we want to show a text that we're still waiting for that player. So text will be waiting for player X. Font size will be 32 SP, import SP, and else if our state connected players does not contain our player O, then we will show the same text just with player O. So depending on who is missing, we will just show corresponding text. And then below this row, so this row is aligned in the top center. So just for these texts here, then in the center of our box will be our tic-tac-toe field, which will now come below this row, this column, of course. And that will be right here, tic-tac-toe field. The state will be our state. And when we tab in a field, we want to say view model finish turn, just like this. And we also want to pass a modifier. So we can say modifier is modifier fill max width. We can say that we want the aspect ratio to be 1f. So we just have a square and it just fills a square shape size kind of. And we want to give it a bit of padding of 16 dp from all directions. One thing before this, or actually we also want to pass some other values maybe. Play X color, play O color, no, let's not change that. One thing before this tic-tac-toe field is we also want to check if, like, who is next. So once two players connected, then there will be this next is O text. And we want to find out who is that, or rather show who is currently at turn. So if state, let's put that on 2 lines actually. If state dot connected players dot size is 2, so if there are 2 connected players and the winning player is null, so if there is no winning player yet, and the board is not full, then we want to show this text who is next. So we can say text is if state dot player turn is X, then we say player, or just X is next, and else we can say O is next. And the font size is also 32 SP. Want to make sure that we align this text properly in the top center. So also just right here. And then what else is missing? Actually only the message when someone won or when there is a draw. That we also show this as a text, and we also want to show a progress bar when we connect. So below this, we're going to have another if condition based on our state. If state dot is board full, or we have a winning player, then we want to show a text. And that text will be when state at winning player, if that's X, we will say X or player X1. If that's O, we say player O1. And else there is no winner, so we can say it's a draw. We can set the font size to 32 SP again. And we want to attach a modifier of, let's say, padding. We assign some bottom padding to just offset this a little bit. We can say we want to align this in the top, actually in the bottom center this time. And that's pretty much it. So the last thing we want to consider is showing our progress bar, which is also very simple. So if our state is connecting, or actually if we just are connecting, that's not contained in our state, we want to add a box that just fills our whole screen. So modifier dot fill max size, give it a background of white, and center its content. And then in here, we're going to have a circular progress indicator. Now that's everything for our Compose code. This should be our whole UI. The really last thing we need to do for our app is we need to set up Dagger Hilt. So in our root package, let's have a DI module, a DI package. And in that, set up our app module where we will provide our dependencies, such as our client and our, I think that's it, just our client. We annotate this with module. We say we install this in the singleton component. So we just make sure all these dependencies in this module live as long as our application does. And in here, we're going to say function provide real-time messaging client, which will need an HTTP client, return a real-time messaging client, and it will just return a Ktor real-time messaging client. So that's the specific implementation we choose here. We need to make sure to annotate this with provides and with singleton to just allow a single instance of this throughout the whole application's lifetime. And before this, we need to provide our Ktor client. So we again, have a singleton provides, and we provide our HTTP client here like this. And this will be very simple. We can just say return HTTP client, this green thing here. The engine is CIO. That is what we included as a dependency, since that supports WebSockets. And in here, we can just configure that the same way we did that server side. So we can install specific features, and we want to install the logging feature. And we want to install the WebSockets feature like this. And that's it for our module. We need to also create an application class to set up Dagger Hilt. So in our root package, let's make an Tic Tac app. Make sure that inherits from application. And we annotate this with Hilt Android app. So that is nothing new to those who watched my Hilt Basics course. If not, of course, I went through this a little bit faster, but I really recommend my Basics course about Dagger Hilt, where I talk about in detail about everything in Hilt. So in case you're curious how this works, then simply watch this video, just Philipp Lackner Dagger Hilt course or so in YouTube, and you will find it. In our manifest file, we need to add our application's name, Tic Tac app, and I'd also like to add uses clear text traffic and set that to true, since we don't use any encryption here, so we don't have an HTTP, an SSL certificate for our server. You could, of course, set that up with Hostinger. That is absolutely not a problem. But just to not make this too complex here, I will leave it at HTTP. And we're also not dealing with super sensitive user data here. So since we don't have anything authentication related. But of course, if that would be a real app, I would always make sure to have an SSL certificate. So you actually don't need this option to allow like WS and HTTP traffic. So I hope that is everything we need to implement here. And I would say we just try this out, and I will run this on both my devices, on my Pixel and on my emulator that is currently running here with my other app. So we can just, I'll just delete this while Gradle is building. Oops. Because sometimes I have these memory issues with my emulator. If I have too many apps installed, I just have one. Well, let's install this here as well. And right now, my Pixel says couldn't connect to the server. What's the issue with that? Well, if we take a look in IntelliJ, we see that our server is not running. So we already see that our error message is working perfectly fine because we could not connect to our server. Let's make sure we actually run this. And obviously we also, I think we're missing the port. So right now our server is running, and it is running on port 8081. You of course need to remember your port if you change that or not. And then in our Ktor real-time messaging client, here we want to also append the port. So we want to say 8081. And then relaunch this on both my devices. And you will see X is next. That looks quite good. And on my emulator, we also see the same. I don't know who is X, but if we click in a field, then that seems to work. So we can play. Let's click O, then we have X again, like this. Go here, and let's say player O is now winning. click in here, actually here, and then it says player 01, and that seems to work just fine. Now X is next. We can play the game again. Let's see what happens if X wins right here. Then it says player X won. That looks very good. And let's also try it out. What happens if we have a draw? Let's create that here. I never know where I need to click. Like this. Then here X, O, X, O, and X. And then it says it's a draw. So everything seems to work perfectly fine. We can play as many rounds as we want. Obviously, only 2 players can use this app, which is like part of your homework to actually extend this, so you can, players can actually create rooms where they can play, so that your app can be used by more than 2 people. But that is definitely a start, and you can, that's a great homework to actually extend this so you can play this with, so more people can play this than just 2 people. But we're not done yet. So our game is working, obviously, but we still want to deploy our backend. So right now we can only play this via localhost with people who are in our Wi-Fi, but usually you want to play with your friends who are somewhere else and not at your home. So how do we do this now that we get a server on Hostinger and deploy our backend there so that we can play this game with anyone on this planet? So what do we all need to do to finally be able to deploy our backend to a Hostinger VPS instance? The first thing is we obviously need that instance. So we need to go to Hostinger now, and right here, as I already showed you a little bit at the start of this video, you make sure to go to VPS hosting, and then you will get to this page. And I choose this VPS 2 option, which is perfectly fine to start and also for your first few users. If you really just care about deploying this once and testing it, the VPS 1 option is fine. And of course, if you have more users, then you need more storage, more RAM, and all that stuff. But you would then simply go to select here for VPS 2. And then you will get to this page, and of course don't forget to apply my discount code here. Click on have a coupon code again and enter Philipp 7, and you will get an additional discount here depending on which plan you actually choose. You could also just do this for 1 month to try it out, but of course it's you will save more money if you do it for a longer period. Once you did that, you will get to this Hostinger web panel. And here you will have this option for this VPS server plan 2, where we can set this instance up. That is what we want to do now. We click on setup and click start now. And now we need to select a location for this. Obviously, this should be close to where your users are. For me, that will be in Netherlands, but wherever you live, you should use whatever is closest to your place or to your user's location. Click continue. Here we now need to choose an operating system for our VPS instance. So in the end, that's really just a computer that we can access remotely later on using SSH. So that's just a command line tool to send commands to a remote machine, such as this VPS instance here. And we need to now install an operating system for this. We have the option to have an operating system with control panel, plain operating system, or a game server. Game server is obviously not what we want here. No, we want this control panel to just have some additional options. We don't want CentOS, which is all Linux based here. Instead, I don't want to choose that. I want to choose a different control panel. We want to choose an Ubuntu instance. That is what I usually use for my VPS servers. So here we have a bunch of Ubuntu versions. I want this Ubuntu 88.04 with webmin. So we select that, click continue. And now we need to set a VPS host name and a password, which we then need to connect to that VPS server. So for example, here I will choose Philipp Lackner .tic tac toe, but choose whatever you want. This is not too important here what the name of that server is. We need to assign a password, which I will type here. Then we want to add an SSH key. So what is that? An SSH key is basically something we push to our server once, and then we also have a private key of that, which is local on our machine. And with this private key, we can easily connect to our server without needing to enter our password. And this will be important because later on in IntelliJ, we will set up a Gradle task that will allow us to automatically deploy our backend to our VPS instance. So we don't always need to kind of manually send our jar file that we will generate to our server, relaunch the server there. No, we will set up a script that will automate all this. And to be able, or to allow Gradle to automatically connect to our instance, it's very helpful to have such a key. And the way we will get this key is, first of all, we want to specify the name of that, which is default. We want to launch a terminal tab. So terminal, and in Windows you would use CMD, or rather I would recommend to use git bash on Windows because that's more like a Linux terminal. I'm not sure if the command we use here is available for the normal Windows CMD or PowerShell, but with git bash it's definitely available. So then this terminal tab will open. You can make this a bit bigger, and we want to make sure that we are in our actual users folder. Then in this users folder, this will also be the same for Windows, we want to cd into .ssh, and this is a folder which contains all these key pairs, these SSH key pairs that I talked about. So if we click ls here, then we see a bunch of keys for different servers that I accessed in the past. And for everything that now happens inside of our terminal, I actually prepared a little helper file, a little helper gist, which is not for this video, but it was for another video where I created a Ktor server in the past. So I can just drag this over here. We can go back in our terminal and we can just follow these steps to finally be able to deploy our backend. It will differ a little bit than what is mentioned here because back then I think I used Windows and some things were done differently, but let's just do this together and you will see what we actually need to do and what each step does. So here, we first of all, so we don't want to download git bash since I am on Mac here. We want to generate an SSH key pair with this keygen command. So we say SSH-keygen PEM, which is the type of key, and the algorithm we want to use for this key pair will be RSA. So you don't really need to understand the details here. It's just important that you can create this key pair. We then click enter. We need to specify a file name now in which we want to save this key. And let's just choose Tic Tac, Tic Tac Show. Press enter. We could also protect this key with an additional passphrase. We don't want this because then we would need to put this passphrase in our Gradle file, or we would need to kind of read it from somewhere else. Let's just ignore this. The key already serves kind of as a password. And then, yeah, after that, it will be done. We can clear this with Control L and we can list our files here. So now we should be able to see, okay, I misspelled this, but whatever. We can see our tic-tac-toe. The one without an extension is the private key. That's really private. You shouldn't send this to anyone. With this private key, anyone can access your VPS instance. This key with the pub extension is the public key, which is really public. You can see this. Everyone can see this. Nobody can really do anything with that. That's the key the server will now get. So the server hosts this public key, and whenever a client tries to connect with a key, the server will actually only allow private keys that work. So in our case, since we have a working private key, we can then easily just access our server with that. But if a client does not have a private key that fits to this public key, then it won't work. So what we can do now is we can say cat, and we print out our public key. This is the key that we now want to copy. We want to copy it until this last equal sign, so without this path name here. Copy this and actually go back to our Hostinger dashboard and simply paste this here. So that way we just set it up to work with our private key. We then click Save and Continue, click Finish Setup, And then we should see this progress bar, which might take a few minutes. And after that is done, I will see you back. So there we go. That was successful. Let's click on Manage Server. And here we get all the information that we need to know about our server. This is our dashboard. And whenever you need to, for example, relaunch your server, change anything like the password, for example, this is the place where you need to go. However, what's interesting to us now is this IP address that we were assigned. This is the public IP address that we will now use for our app to connect to the server. But before that, we of course kind of need to take our Ktor backend, package it into some kind of executable format, which for Java frameworks or Java languages is a jar file. So we need to take this jar file, push it to our Linux machine, to the server, and run it there. And then it will be accessible for our app as well. So what we want to do is we want to take this IP address, copy this, go back to our terminal, and here we now want to connect to our server using SSH, as I said. So SSH is just a tool to run shell commands directly on our remote server, because somehow we need to send commands to it, somehow we need to install stuff on our server since we don't have a visual interface for that. So what we'll do is we will say SSH, and we want to specify a key which we will use to connect to this. That is the private key that we now generated, and we can specify that with -i. The name for that is this one here, which I misspelled. And then we refer to root, that is the user as which we want to connect. And since we have root privileges, we want to also use these. And then we say @ Now we specify the IP address, which we can paste. And that should be everything. So if we now press enter, then we can type yes, press enter again. And now we can see we are on our server. So now whatever we write here in our terminal will not be executed on our local machine, it will be executed on our server. So we can clear this again with Control L. And the first thing we want to do is we want to write apt update. So that will simply update all the dependencies for specific programs. So we can just find all these programs that we need. For example, we want to install the JDK, so the Java development kit that we can actually run our Ktor server later on here on this Linux machine. When that is done, we can clear this again, and then we want to install Java. We can do this with apt get install default-jdk. Press enter, and that will take a little moment. We need to type a Y for yes, press enter, and then it will simply install Java here on our remote machine. When that is done, we want to clear this again, and I want to move my other browser window here into this window again and check what is next. So the next thing is we need to open this sshd config file, because we need to add this line into this file, which I mentioned under point 9. And again, you can find this file also down in this video's description, because later on the tool we will use in our Gradle script to also communicate with our server via SSH and SCP. SCP is pretty much SSH, but just that we are communicating with files. So we can send files to our server and download files. And with SSH, it's more about sending commands. But the tool we will use for that in Gradle actually needs this line because it uses some kind of key exchange algorithms which aren't specified by default. And to do that, to also support these, we need to add this line. So we want to say nano /etc /sshd_config. And here in this file, I want to scroll completely to the bottom and simply add this line here. So we copy this, paste it here, and then with Control S, we can save this file, and Control X, we can get out of this file. Then we need to write systemctl restart sshd. So we just restart that service, which is responsible for loading that config. And then we need to create our own service. So with this systemctl command, we can basically create a service that runs a specific file. In our case, that will be the jar file for our server, and it will make sure that this really always runs, because our server should, of course, always be reachable. Also, if our VPS server will be rebooted, then with the systemctl service, we make sure that also our Ktor server will automatically be rebooted, or just put into the auto start kind of. So we want to say nano /etc/systemd/system. And in this folder, we want to create our own service. And for that, we need a config file. This config file will in this case be called Tic Tac Show.service. And this is of course now empty. In this file, we want to paste this config, and I will explain the most important points of that. I already explained all that in the previous video where I talked about where we build an authentication system with JWT, but let's go through this again. So here we paste this config. We can rename this auth service to, let's say, Tic Tac Toe service. After network target means this will only run after our server is actually connected to the network. Here we specify some kind of like time constants. I'm actually not sure what this does. It's a simple service. We always want to restart this in the user's root. That's important. This environment file is not needed. This is only needed if we would have environment variables in our server, in our Ktor environment that we would need to access. We don't have that here. And the most important line is this exec start. This will be the command that will be run together with our service. So here we really want to launch our jar file, our Ktor server's jar file, which we of course now need to specify here. So we refer to the Java command here. We say we want to launch a jar file, and the jar file's location will be at /root/ not JWT auth in this case. We will say tic tac toe, and the name of the jar file will also be called tic tac toe, like that. So if we now click Control S, then we save this, and Control X to get out of this. We can now try to run this service by saying systemctl start, and the name of our service is tic tac toe. And if we don't get any errors, that looks good. Of course, nothing will happen right now because we haven't pushed our jar file to this VPS instance yet. But before we do this, a few more things that we need to configure here. We want to say systemctl enable tic tac toe. This will effectively set a symlink, so that will make sure that our server will also launch together with our VPS instance. So if we relaunch our VPS server, then we will also directly launch our tic-tac-toe server together with that. And now the last few things we need to do, as you can see here, make sure your ports are open. So we need to kind of open our ports. That means that we make them accessible for the public, at least the port where our application is running on. And we need to do this with this IP tables command. So we can copy this, paste it here, it will automatically execute that. And then we want to also execute these two lines where we will basically say, hey, port 80 should be open and port 8080 should be open, which is the port we will then run our server on. So let's do this. And by the way, this first line set up a pre-routing, which means that we forward the traffic from port 80 to 8080. So we don't always need to type the port 8080 when we access our server, because this is the default HTTP port. So we can now paste the second line, press enter, and we can copy and paste the third line and press enter. And then, since these IP tables commands are just temporary, so as soon as we relaunch our VPS server, these will actually be reset. We want to save these, and for that we need to install IP tables persistent. So apt get install IP tables persistent, which kind of, just saves these and reloads these when we reboot our server. So we press yes, and then we will be getting a little window here where we also want to press yes that we want to save our IPv4 rules, we want to save our IPv6 rules, and then we are good. And we just made sure that we always have these rules that we just set up. And the last point here is not relevant for us since we don't need to set any secrets. Cool. So if we now clear this and actually go to our root directory, this is the directory where we actually want to put our jar file later on into the tic-tac-toe folder. Right now, if we type ls to list all files, there are no files. So what we want to do is we want to create a directory with mkdir, and that will be called tic-tac-toe. So we just want to make sure there is this directory so we can then easily push stuff into this from our Gradle script. So the last part will really only be an IntelliJ. Here we will be setting up our Gradle to be able to just run a single command in our command line to deploy our backend. So it will be packaged into a jar file. The jar file will be pushed to our VPS server, to our Linux machine, and then we will actually relaunch our systemctl service that we just set up, which will then just make sure that our up-to-date or updated server instance will be used. So how will we start? And for this part, I will also copy and paste a bit of code, since for most of that, there's no real reason to write all this off. Again, you will find this down in this description. You will find the latest version of this source code. We want to go to our build.gradle KTS file. And here, the first thing we want to do is, first of all, fix this formatting, which is broken for whatever reason. We want to add a Gradle plugin, which is called Shadow. And this Shadow plugin, which you can find like this, will take all of our Ktor server source code and package it into a single executable jar file. So that's the whole purpose of this Gradle task. With this jar file, we then have something that is executable, which we want to push to our remote machine. However, to be able to push something to our remote machine directly from within Gradle, we need a so-called SSH and task. That is just something we can access, or we can use in Gradle to access commands like SSH and SCP. As I said, to send commands to our server and to send files to our server. And we need to create this definition for this task like this. And then we can add the dependency for this, which we can paste down here, which looks like this. So this just adds the functionality in Gradle to be able to use SSH and SCP in our Gradle tasks. And then the code we will paste down below will be this. So here we use this with Groovy Builder, since we are here in Gradle Kotlin DSL, and this and task is only really defined in the Groovy version of Gradle. So we need to use this Groovy Builder to kind of convert this. And that's why we also have all these quotation marks. But this really just defines these two tasks. So we have SCP to copy a file to our server and SSH to send commands to the server. And the last thing that's now missing here is the actual task that will take our jar file, or first of all, generate the jar file, and then push it to our server. Let's go through this step by step. So here we have our task, which is called deploy. That's how we can call this task later on. And it depends on clean and shadow jar. Clean is basically responsible for just cleaning up our build directory. So it will just do a whole new rebuild after that. And shadow jar, well, we'll just package our server's code into a jar file. And since this deploy task depends on these two tasks, it means these two tasks actually need to run before our deploy task. After that's done, we say again with Groovy Builder, and here we specify a bunch of variables that are relevant for our server. So first of all, a known host file, which just contains some information about hosts that our machine already knows. We just need to pass this here. Don't worry about that. We specify the user, which is root in this case. We need root access to our server. We need to specify the host, which is the IP address, which is not the correct one here. This is my IP address from the server I prepared this for. So we just want to go back to Chrome, and actually not this one, and copy this IP address from our Hostinger web panel again into IntelliJ. So we replace this. Then we specify our key, which is our SSH key, which we generated. This is the private key, which now Gradle, of course, needs to know to be able to successfully connect to our server without needing to enter any kind of credentials like a password. And we need to copy this into a folder of our project just to make sure that we have all the necessary privileges. So we create a keys folder and put in the key, which is in my case called Tic Tac, since I misspelled that. Just replace this with whatever name you chose. So in our root directory, I first of all want to go to git ignore, since this key should of course not be contained in version control, since it's a secret. And here we can just add keys, like this. So we just exclude the whole keys directory, which we'll now create in our root package. Actually, new directory called keys. And then I want to open Finder, where I will navigate to my users directory, going to .ssh. You don't see this here because I don't need to show you that. But just go to your users directory, and then wherever you put that SSH key, take this key and simply copy it in here. Yes, that's a text file, and you will now see only a little part of that. We can close this, and now we have our private key in here, in our keys directory, which we can then access from our Gradle script. Cool. So the next thing will be our jar file name. This will be the file name that is generated from the shadow jar plugin. And I assume we just want tictactoe-all.jar. That's just the name that will be chosen. So it will be generated here in our build directory. Yeah, we need to run this shadow jar task to be able to see this, but I assume this will be the name. Then we say scp, so we run the secure copy. I think that's what it stands for. We run the copy command to copy a file from our local machine to our remote machine. The file we want to copy is located here at build-libs- our file name. The directory we want to push this to is whatever user we chose, so root @host, so our IP address, the same we specified for connecting to this with SSH. And here we specify a specific path. So /root/tictactoe, that's the directory we created in our terminal. We specify the key file, which we set here once. We trust this host and we set the known host file. Next up, at this point, we know that our jar file is on our server. So we now execute the SSH command because we want to, in this case, just rename our jar file on the server. So we say, okay, host is host, username is user, key file is key file. We trust this, known hosts. And here, this is the important part. The command that should be executed is mv, which stands for move. That's the way we rename a file on Linux. So we just take the file we want to move and we move it to the exact same kind of location with the new name. So that way we just make sure that all jar files are called the same. Since that's also the name we specified in our systemctl service we configured on Linux. So we make sure that it will always run the correct instance. And then here in the remaining two commands, we just send the command to stop the current instance of our tic-tac-toe service and then start it again. So we just start the new jar file. And that's really the whole magic that happens here. So if we now click here to synchronize Gradle and actually go to application config, since I want to change this port to A080, that is what we specified in our IP tables rules. Then we should be able to deploy this. I wouldn't be surprised if something goes wrong here, but we can just try this in our terminal. Open the terminal here and say /gradlew. That is our Gradle wrapper, which is used to execute Gradle tasks. And we want to run our deploy task we just created in our Gradle file. Press enter. And it says permission denied for whatever reason. I honestly have no idea why that happens because it's all inside of our directory. Maybe gradlew that will work. No, okay, I probably need to relaunch IntelliJ here with admin privileges, so I'll see you back after that. Okay, it seems like I just needed to run this line to give privileges to my Gradlew command. It seems like that's necessary because this Gradlew wrapper file wasn't created on this machine. Instead, it was created by the Ktor project generator. And yeah, then it seems like it doesn't have these privileges by default. But now that works, so in case that also didn't work for you, just run this line. We can then clear this and we can now try to deploy our backend with our deploy task. So let's hit enter and hope for the best. As long as things are green, it's a good thing. So now things are red. Let's see what went wrong. That is not a surprise. No such file exception. tic-tac-toe-all jar does not exist. Looks like the file was renamed or was named a little bit differently. So in build-libs, we should be able to see, okay, it actually prepends our package name. So let's also adjust this here in our jar file name and say com plcoding.tictactoe-all.jar. Let's rerun our Gradle task and hope for the best now. And now you can see the build was successful. That means also server-side everything went well. Otherwise, the server would have responded with an error message. If we now go back into our terminal, where we are actually on our server, so I'm still logged into SSH. And here in our root directory, we have our tic-tac-toe directory where we can cd into. If we now type ls, here is our jar file that was actually pushed to this server. And this should actually already be running, which we can actually check with systemctl status, I think. And then tic-tac-toe. And yes, it seems like this service is active and running. So how can we now test it, or how can we now connect our app to this specific server here? All we really need for that is our IP address. Let's copy this, go to Android Studio, and we want to replace this part in our Ktor real-time messaging client with our actual IP address. And we don't need to specify the port here, since we use these IP table rules which map the default HTTP port to the port our server is running on. And if we now relaunch this on both my devices, and I need to reconnect. So here it already says waiting for player O, which is good, because if it couldn't connect, then it would be saying connection error. Let's also launch this on my Pixel and hope that we can now play. Yes, we actually get the message access next. We can start to play here, and that looks quite good. Yeah, so we can now play our game, which looks really good. Play X1, then after 5 seconds, we should be able to play another round, and another round, and another round. It's a lot of fun. Let's try what happens if it's a draw. Right here, right there, right there, here. Okay, now I accidentally won, but you can play around with this. I think you believe me that this is working. We also already tested this locally. Yeah, just using this remotely won't change anything in terms of functionality for the game, of course. So again, take it as a homework to extend this to just make sure that players can create rooms where, yeah, everyone can play with a friend, and as many players as you want can actually use your app, and not only 2 players. That will be quite a challenge, but also a lot of fun, I think, and will definitely help you to learn these things and internalize these much better than just watching a course can do. And again, if you're looking to create your own website, I can really recommend Hostinger. We will find all the links down below. Discount code Philipp7. I already showed you that quite often in this video, but I really like Hostinger's services. I'm also using these myself, so definitely do check these out. Thanks for Hostinger for sponsoring this video again. I will see you back in the next video. Enjoy your week. Bye bye.